All right, last example, example 5 says a solution of hydrochloric acid reacts with zinc. So a solution means aqueous of hydrochloric acid. Okay, again, if you didn't know that, check your data booklet, but we've done it enough. Reacts with zinc. Now, a lot of you are going to write this. That's not correct. It doesn't say reacts with zinc ions. It says reacts with zinc. Zinc as an element is a metal, which means it's a solid, and it's an element, it is neutral. Elements do not have charge. When this reacts, I'm going to have a single replacement reaction where zinc and the hydrogen flip because zinc is a cation and so can they can both be hydrogens, so they're going to flip. I'm going to get hydrogen's going to come out and be H2, and I'm going to get ZnCl2 aqueous. Okay, so I'm going to get my reaction. If you're wondering how the 2 got there, zinc has a charge of 2 when I drop and swap in an ionic compound. Now I got to balance this guy. I've got 2 hydrogens, 1 hydrogen, 2. Check. Good. So I've got a balanced chemical equation. Now this question says what volume of hydrogen will be produced? So I want, in this question, guys, I want the volume of hydrogen, and it gives me the mass of zinc. Okay. Now, if I just take all that information that it's given me in the question, let's write it out. It tells me the volume of hydrogen, temperature. Okay. Well, this is a gas, right? So if it's a gas, I probably need to use the ideal gas law. Well, the ideal gas law is PV equals nRT. So T relates to the gas. Oops, dropped my marker. So T relates to the gas because of ideal gas law. So the temperature is 21 degrees Celsius. Now, we know that we hate degrees Celsius when we're doing math. We want Kelvin. So I'm going to need to add 273.15. So you guys can see how these units are kind of meshing right now. Okay. It told me the pressure is 99.6 kPa. Well, I want it in kPa. That's good. If it wasn't in kPa, just do a unit conversion using the table in your data booklet. Okay. And the only thing, so if I want volume, I need pressure, check. R, easy. Temperature, check. Volume, okay. I need the moles. I don't have the moles right now. So I need that. Well, how am I going to find the moles? Okay. Remember, in order to find the moles of one chemical, I need the moles of something else. Let's go back to zinc. Zinc tells me the mass is 5 grams. Do you guys know the molar mass of zinc? You do. I believe it is 65.41 grams per mole. Can you guys find the moles using these? Yeah, we've done it enough. Mass over molar mass. Okay, 5 over 65.41 grams per mole. 0.07644 moles. Box around that number, don't round it. 2 conditions to molar coaster. Balanced chemical equation, check. Moles of one thing, check. I can now ride the molar coaster over here to find out that mole. And then eventually find the volume. I'm going to divide by where I start, which is 1. And I'm going to multiply by where I'm going, which is 1. So the moles stays the same. And now I have T, R, N, and P. I can find V. So I'm going to rearrange my formula. I'm going to say I have to divide both sides by P. Okay, so I'm going to say V equals nRT over P, which is 0.076 moles times 8.314. Don't forget your units. I just can't write them because I'm running out of room. 294.15 Kelvin divided by 99.6 kPa. All the units will cancel out except liters because that's my volume measurement. So I'm going to do N times 8.314 times 294.15 divided by 99.6 kPa. I'm going to get 1.8769 ... liters, 3 sig digs, 1.88 liters. So again, was this process, guys, any different than other examples? No. Step 1, chemical equation, balance it. Okay, so you have to think. If you are having a hard time generating chemical equations and balancing chemical equations, this unit could be challenging for you, and grade 12 will be challenging for you. But for now, balance the chemical equation, check. Second requirement, I need the moles of one thing. So write all the information down under the right chemical, find the moles of whichever one you can, use the molar coaster to find the missing moles, and then rearrange the formula to find the new information. Process doesn't change, but how we find the moles can change. All right. And that's it, guys. That's the molar coaster.